Hello, my name is Jaehan Oh, who will be presenting fourth week of Group 6 in the 2 division of 특화설계. I will start the presentation now. The presentation order will be a Gantt chart that will show the progress of our group's project and feedback through the Q&A last week. Also, we will proceed with the mechanical analysis through the defined dimension, and we will summarize today's presentation and finish the presentation. This is our Gantt chart. This week we conducted a mechanical analysis too. This is the basic specification of our ashtray that we've explained before. The main questions that came out last week was about the efficiency and economics of solar cells. Solar cell charge per day is approximately 400 watt per hour. We can run the motor even if we have a cell-phone supplementary battery charger. So even considering the minimum wage, it is economical. This is the order of our mechanical analysis this week. We determined dimensions, materials, and loads. The most important consideration was the supply rate of the sandbox and the rotational speed of the ashtray main body. Once the above have been determined, the motor for the product can be selected and the appropriate diameter can be determined by the torque value of the motor. The sandbox and ashtray were to be made of STS-304, which is 2 mm thick, and the mass of the two parts was 5.58 kg and 5.3 kg respectively. The most important mechanism was to obtain the time per cycle of sliding doors in the sandbox. The sandbox should fill the ashtray with 300 ml of sand once it is emptied, so we decide to use crank and slotted lever. Its speed goes by a ratio of 2 to 1 when it is opened and closed. It depends on the angle of the gear, and we actually got the experience value of 300 ml of fine sand being discharged. In conclusion, after 16.2 seconds per cycle, 300 ml of sand is discharged, and within the time, 120 degrees of ashtray should be rotated. We choose the motor to connect to the solar cell as the one shown on the slide. It is a motor with a direct current of 12 volts that can rotate 30 times per minute and produce 4.018 Newton meter of torque. And this is the specification of motor. We got the RPM of the shaft through the cycle time we got earlier. Because the motors and shafts have different RPM values, torque was obtained through the ratio of RPM values. The mass of the gear was 0.3 kg and the mass of the ashtray was set 6.28 kg. And we're drawing a free body diagram. Shear force, bending moment, torque diagram was drawn through the interpretation of the free body diagram. Using the yield stress of ASTM A36 steel and setting safety factor to 5 and set the diameter of the shaft to 12.5 mm. To summarize today's presentation, to determine the diameter of the shaft, prepare to solve the given problem through the time which we measured, required for one cycle and the supply rate of the sand. In conclusion, the appropriate diameter for the shaft was determined through the calculations of the forces applied and the materiality of the used material. Thank you for listening our presentation, and if you have any questions, I will answer them sincerely.